This video is going to be focusing on the law of sines. A lot of what we've been doing in class is dealing with special right triangles, but what you're learning about today, the law of sines, and what you're going to learn about in the next video, which is the law of cosines, these work for any type of triangle, so it doesn't have to specifically be a right triangle. And for the law of sines, whenever you're given any triangle, what we could do is we could write ratios. For sine of an angle over its corresponding side equal to sine of another angle over its corresponding side, instead of equal to sine of the last and third angle over its corresponding side. So the way that we do this is, let's say that this is angle A. The side that's opposite to it is its corresponding side. And if this is B, you can see the side opposite is its corresponding side. And then if this is angle C, the side opposite is right here, so that's its corresponding side. So again, we're just writing trigonometric ratios, that's all. We're going to solve for missing links. You can only use this law of sines, so writing the ratios, when you have angle-angle side or angle-side angle and side-side angle. You learned these in geometry, but just in case you need a quick review, angle-angle side, let's say that this is my triangle right here, would be two angles. So let's just say it's these two, and a non-included side. So let's say I'm given this one right here. Non-included just means it's not in between the two angles. So you can see how it's angle, angle, and a side. Angle, side angle is when we once again have two angles. So I'm just going to draw it like this. And the side is included. So you'd be giving this measure. If you want to make a little note, this is a non-included side. An angle side angle has an included side, which once again just means it's in between those two angles that we know the measures of. Side-side angle is when you have two side lengths and a non-included side. So a non-included, or excuse me, angle. A non-included angle. So if I were to have a triangle like this, you'd have two side lengths. The included angle would be in between these two lengths. So this right here is an included angle, which would make it side, angle, side, which it cannot be used with the law of sines. So instead I want side, side, angle. So I can either use this one or this one. I'm just going to put one here. Okay, so a non-included angle. Example 1. The first thing that I want to go over is which rule is it? So you have a measure here, a measure here, and those are both angle measures, and then a side length, RT. I have two angles, and this is a non-included side. The included side would have been this one right here, T. But this is a non-included. So this is angle, angle, side, which can be used with the law of sines. Whenever it says solve the triangle, you need to solve for any missing angles and any missing lengths. The first thing you should do is look for missing angles. So I need to solve for angle T. And it's actually quite simple the way in which I would solve for angle T. We should know that all triangles sum to 180 degrees. So I'm going to take 180 and I'm going to subtract the two measures that I already know. So 180 minus 40 minus 49 gives me 91 degrees. And now we're ready to begin writing our trigonometric functions, or excuse me, ratios, which are right here. Sine of an angle over its corresponding side. Sorry if you hear the dogs running around. Okay. So I always like to start with the ratio that I already know. It might be easiest if you go ahead and write out all of the ratios so we can determine which one we want to use. Let's go ahead and just write, I like to write my initial ratio in alphabetical order. So it goes in the ABCs, R, S, T. So sine of R will go over its corresponding R length. Sine of S will be over its corresponding S length. And sine of T will be over its corresponding T side length. Okay? So sine of R. R is 49 degrees. So I have sine of 49 over its corresponding length is going to be opposite. Now it just says R, so I don't know what that is. Equals sine of S, so S, it's all the way over here, it's 40. And sine of 40 is going to be over its corresponding side, so across from that is 20. Sine of 40 over 20. And now we have sine of T. So T is right here. It's 91 degrees. And across from it, its corresponding side is T. So we want to use a ratio that has both measures given to us. So this right here is going to be our ratio. And what we're going to do is we're going to use this ratio to solve for R and T. The way we do that is cross multiplication. So we're going to write one equation that is our ratio, sine 40 over 20 equals, and you just pick one that you want to solve for first. Let's say I want to solve for R first. So I'm just going to put equal to sine 49 over R. And then we're just going to cross multiply. So if we cross multiply, I get, I'm just going to write the next step right here. It's R sine of 40 equals 20 sine of 49. Don't plug this into your calculator yet. What I need you to do now is just solve for R. The reason why I say don't plug it into your calculator yet is because if you get approximations too early, your answer may be slightly off. Whereas if you wait until the very end, you'll be closer to the actual answer itself. So when we plug this into our calculator, I'm just going to show it to you on a TI 30X because this is what most of you use. You're just going to plug in the numerator exactly how you see it. So 20 sine of 49, right? Yeah, 49. And then at this point, I would hit enter and then divide by sine 40. So I get approximately 23 point, it said to the nearest tenth in the directions. So you see how that's going to be 23.5 because the 8 will boost the 4 up. So that's R. Now we have to write the answer, and use a different pen, for T. We once again are going to use that ratio that we set up and set it equal to the other ratio we haven't used yet. So that would look like sine of 40 over 20 equals sine of 91 over T. Just cross multiply, so that gives me T times sine of 40 equals 20 sine 91, and solve for T by dividing by sine of 40. And then just practice plugging it into your calculator. I'll do the same. I'm doing 20 times sine of 91. I hit enter just to find out what that is, and I divide by sine of 40. I get approximately 31.1 because it's set in the directions nearest tenth. All right, example 2. I'm going to go through this one a little bit faster, especially since you can probably hear the dogs running around and playing. It says to solve the triangle and round to the nearest tenth. So the first thing I need to do is find the missing angle, which is 180 minus 141 minus 23, because all triangles sum to 180. If I do that, that gives me 16 degrees. Now I'm going to write my generic ratios. I like to do it in alphabetical order, so sine of D over D, sine of E over E, sine of F over F. And let's just plug it in. So sine of D, so D was 16, over D, the side length, so the opposite, which is right here, that's 9, equals sine of E, which is right here, that's 141, over E, that's the opposite length, equals sine of F, which is right here, that's 23 degrees, over its corresponding length F. Now the ratio is the one that has both of the measures. So that right there is my ratio. And I need to set this ratio equal to each of the other ratios and solve using cross multiplication. So I'm going to solve for E first, just because I want to. It doesn't really matter. Sine of 16 over 9 equals sine of 141 over E. I'm going to cross multiply. So that's E sine of 16 equals 9 sine of 141. Divide by sine of 16. E is approximately, I'm going to plug it in. By the way, notice how instead of writing an equal sign at the end, I'm writing the approximation sign, which looks like two squigglies. I'm doing that because it's not an exact answer that I'm finding. It's just, like I said, an approximation. So E is approximately 20.5 because it said round to the nearest tenth. You can see how there's a 4 after the 5, so it stays. It doesn't boost up. Now we have to solve for F. So I'm going to do sine of 16 over 9, that was my ratio, equals sine of 23 over F. And we're just going to cross multiply once again. So really, the hardest part is just writing the ratios, because when you actually start solving the problems, you see that we're repeating the same process. And if I plug this into the calculator, that's 9 sine 23 divided by sine of 16. I get approximately 12.8. Oops, 0.8. Because it was 12.75, but that 5 boosts the 7 up to an 8. At this time, I would like you to pause the video and attempt problems A and B, and hit play when you're ready to check your work. For try problem A, the first thing you should have done is solve for the missing angle E, which was 119 degrees. Then you would write your ratios, and you should have seen that F was the one that we'd want to use because we knew F, the angle was 28, and then F, the side length, was 15. So I set up my two equations and solved for E and D. Feel free to pause so you can finish checking all of your work. And then here's B. First thing you should have done was solve for angle P by taking 180 and subtracting the values you already knew, so that gave you 105. If you set up your ratios correctly, then you would have seen that P is what we wanted to use because P, the angle measure, is 105, and P, the side length, is 10. So then I just set up my two equations, used cross multiplication, and I wrote my answers. Notice how I'm using approximation notation, which I do expect you to use because that's the proper notation, and I rounded to the nearest tenth, like the directions said.